Let me say something real quick.
Yep.
So also, I think what I'm going to do too, we haven't done it as of yet, but with the lecture slides, I'm going to put those into Canvas. Yeah, so you guys can review. Like, say for example, the first one that we did with Richard had a ton of tips. So by next class, they'll be up.
Yep. So going first to the wiki, just to go over a little bit. I know I went over this already, right? But I just wanted to show you some of the stuff that I'm going to use some of the stuff that's in here to show you the tips and tricks. So most of everything is through these links here. There's also some down here, rendering hints, tips, and tutorials, etc. The ones that I kind of wanted to show you that kind of interesting are, the first one is on a side note, this person here, Simon Reeves, I've never met him, so I don't know him, but I found his render calculator and I advertise it, so if anyone knows him, maybe, tell him thank you. But anyway, if you ever wonder about render times, right, basically this will do a quick calculation for you as to how long any given render will take. So let's say, you're hitting a deadline, you're going to be in a week or 2 days, or it's due the night, in the next day. How much can I render, right? What's nice about this calculator is it'll do, like, for example, if you have a 10 minutes per frame and you have, say, 100 frames and maybe the render farm's only going to give you 10 machines, you know that your current time, it'll take an hour to render on 10 machines, and that's your finished time there. But he also has an allowable frame time. This is kind of cool. So you can put in how long you have left, right? Which is often more important than how long you're going to go. So if you say, well, it's due in, say, 4 hours, and you have, say, 500 frames, and you maybe have 10 machines, your render time has to be 4 minutes a frame, right? So if your stuff is simple, not bad, but if your stuff isn't that simple, maybe not. But on the farm, maybe you get 20 machines. Now it's down to 9 minutes per frame, right? So as the kind of things that this is super useful. It's on links on the wiki, or just look for Simon Reeves render time calculator. It's pretty cool. So just to mention that one. We use it a lot for thesis. I show it to people. If you're like, wow. And I'm like, yeah, use it. It's great. There's also a link here for PBR rendering from the people who make Substance. I'm not going to go over it because it's a whole long thing here. The Theory, Volume 1, right? Volume 2, right? Super cool. If you haven't read this yet, it's great. It'll actually go over, if you're taking Andy's class or other lighting and rendering classes, this first part is actually part of what he also teaches. He'll go into how the light rays work and so on and so forth. But also really great to get up on this, because the specifics of the render, whether it be Redshift, V-Ray, Arnold, RenderMan, or whatever, right? Pretty much all the renderers, the fashion nowadays is that they are physically based rendering, which is what PBR means. And so no matter what renderer you're using, the specifics of what knobs to turn, right, you have to learn that, but the theory behind how it works are all the same. They all use the same algorithm, just every company's trying to optimize it in different ways. So that's why they put this out. Really useful to read that. And then as well, there's hints and tips on Arnold, and I know I got to update this. This is really old here, but it's generally useful, but like the Arnold render settings are not updated. And so what I'm going to do today is I'm actually going to, Josh is going to go over that too, so I'm not really going to go into the settings for rendering so much, but I want to show you a little bit on setting up a scene for rendering so that it's ready for render farms and things like that, and some considerations of when you're getting ready to render. Now this, not just for thesis, but also for your projects. I know it's November, almost November. I don't know how many of you have a big rendering project that's coming up. This stuff's going to help you too, right? And you're probably going to want to use a render farm. And so if the bigger your project gets, the more kind of these settings are going to matter, right? So you've seen this before. I showed this couple weeks ago, I think, is just the natural history set from that I downloaded off of 3D World. And just using it as a demo here. And you can see via Arnold, I have my Arnold viewport. There we go, right? It does it in the viewport now, which is really cool. I didn't do any surfacing on this. This is straight Lambert shading from the source. So I didn't do any surfacing, no tweaking of anything in this shot, just to see if it would work, and it does. So I'm suitably impressed by, what it does. And I'll show you the same scene in the other renderers as well. But to get to this point, right, I'm just going to go over a lot of the things that I see common things that keep popping up. The first one everyone here knows, but I know I hit this with a stick and like a dead horse, right? And it's not even dead anymore. It's like a pancake, right? But set project, right? You know to do this, right? So hopefully I don't ever have to encounter this, having to tell anybody this again, because it's 8 years now, and at least 4 people every year come to me and say they didn't know to do this. So nobody here is going to come to me, tell me that they don't know that, right? So set project, right? I've set my project to my prod folder, and you can see in the title here, prod class R. Hagen, natural history, right? So that's the first most important step. Once you get over that barrier, it becomes a lot easier. If you don't do that at first, it becomes harder later, right? We actually had somebody yesterday, a senior, ask me about references. And so a quick, a lot of you know what they do. I'm not really going to go too much into them here. I don't have any set up in my scene here. But what is the difference, sort of references versus an Alembic cache versus Arnold files? There is a kind of confusion over what you should use to make your scene and render with, right? References are awesome up until you render with them, which unfortunately what happens is Deadline will technically work with references. It's supposed to. It's how Maya works. But if you have live references in your scene and put it to Deadline, if there are any errors, they get worse, right? So my instructions that I went over before, and we'll continue to go over it, is you import the references before you send it to Deadline, but then you make sure you save a copy of it, right? So in this case, my scene doesn't have any in them, right? And if I wanted to, I could maybe make one. I can create a reference here, and maybe I could do the Redshift test here and just see what happens in my scene with that one. All right. So you can see it loaded in, right? Now, if I wanted to working with this is going to make it easier. The reference of the Redshift test or whatever, you can modify that separately, and it will update the next time it loads into your scene, because it's considered a separate asset and isn't actually in your scene yet, right? And that part is what makes the Deadline render farm upset. And just so you know, it's not really Deadline, it's Maya Batch. Maya Batch gets upset by its own feature. So I don't know how that works. But when you have basically, when you're ready to render, what you do is you go File, you go Import Objects from Reference, and you just get it out of the window. The window should be clean and clear before you send it to Deadline. And if you're saying, well, what if I unload it, right? No, you gotta get it out. This window is clean, right? And if you do have references you don't want, right? There is something, you'll notice something else. So if I do it again, right? Let's try a different one here, right? If I unload it, right? You'll notice one thing is now I can't remove it. So if I select this and I go here, I can't actually remove it. It tells me you can't do it, right? Well, in this case, it says it's undoable. It didn't really load in. It actually should allow me to do it here, but I've seen it where it doesn't let you do it anymore, right? So the key to this is if you have a reference that is not supposed to load, but still in the window, and you want to get rid of it, click it, load it, and then remove it, right? And now you can do remove it, and now it'll go away. Right? So that's safe to do. So this should be blank, right? Then what you do is magic. Save scene as. Don't overwrite your original scene before you send that, because you don't want to ruin your references, because that's your whole key to flexibility of your scene, right? So when you hear me talk about references are imported and don't put them on the render form, that's all we're saying. References are awesome, right? So just not on deadline. So to give you a side story on that, we once had a senior that took my words to heart, but didn't quite listen to the other part of it that I said save as. And he totally imported his references on every single shot. He had about 40 shots, and then he realized he saved over them, and then he had to update his character. He had to do it for all 40 shots. Painful, right? So yeah, don't do that. Now the next part is, as you're doing that, before you send a scene to render, right, you should probably clean it up a bit. So I know I've showed this before, but so you know, it originally took me, when they first introduced this feature, it took me a month to find it. Right, it was right there in front of me, but I didn't know where to look for it. It's General Editor's File Path Editor. What this does is it finds all of your assets that are in your shot. Now, this doesn't have any bitmaps. There's no references. There's no XGen files. There's nothing extra, so it's blank. But if I have any texture files or other assets, they will show up in this list. And the key to it is it's really simple. If you see a green check mark, you're good to go. If it's a red X, you got to fix it. All right, that's it. It's really simple. But quick way to fix it. If you're doing a repathing, if you know it's in your prod folder, but it's not finding it, right? This button here will answer your problems. Repath file, you tell it, search, you find your new path, whatever that path is. Search subdirectories, you can even repath the currently fine files if you want, and just do repath, and in this case, it's not going to do anything, so it's not going to work because there's nothing there. But it will search through your file structure and find your files, and it'll all turn green and you're good to go. If it doesn't turn green, then you have to manually fix it or delete it if you don't need it, right? So that's another, the second thing you got to do when you're preparing to render. Third thing you want to do is, now you should save your scene before you do this, because this is destructive. This part will delete things, and you're letting the computer decide what to delete, right? Not you. So it's under File, Optimize Scene Size. You go to the options. And so this is a script, and this script has been in Maya for many years, and they call it Optimize Scene Size as if that's all it did. It actually deletes things, errors that you don't need. Old nodes, you may have found like, this scene has mental ray nodes. How do I get rid of them? This will do that for you. So it has a couple of different features. You can click on the boxes and just do them all at once, right? But that may destroy your scene. You may actually find it explodes. I've seen that. The character is there, he's posed, and I ran everything, and it literally exploded. The character went boom, right? So obviously not ideal, right? So what I had to do was you click on each one individually with the buttons here and find out what makes your scene explode, and just don't do that one, right? The most useful ones are actually rendering nodes are pretty good, and unknown nodes. Those are a pain in the butt, right? Get rid of those. Unknown nodes are the ones that most often cause rendering errors on Maya Batch, right? So this one is a good one to do. This one, on the other hand, shading networks, never do that one. It destroys your shading. It's awesome. It's a destroy shading button. I don't know why it's there. It's remove duplicate, but how does it know? To give you some background on what this script does, it's basically just a script, right? And you know how it knows what to delete? It doesn't know what to delete. It uses its own logic as to what is empty or what is unused. What is unused, it's not attached to a mesh. That's it. So if you have like Arnold and V-Ray love to put on entities like fog or atmosphere as a node by itself. It doesn't exist attached to any geometry. It's just there, right? Arnold knows what it is. Maya has no clue. And so if you do unknown nodes or unused rendering nodes, right, guess what? Your atmosphere just went bye-bye. So know that either there's two ways to do it. Either attach it to geometry or just know that that's going to happen and don't do rendering nodes, right? So you'll see when it happens. But other than that, this gets rid of a lot of cruft out of your scene and is super useful for clearing up errors. You might be surprised what it finds. You'll be like, what are these files that it's finding? It'll give you a whole record. After it runs it, if you click on your script editor, it'll actually show you what it runs. So I'm going to try to run it on this scene and see what I get. So if I go here, I'll just click everything and let's see what dies. I don't think anything should die, but who knows, right? Optimize. It says it's not undoable. This is not exactly true, but you know, it will run out of undos after a point. And you can see it's pretty clean, right? So it didn't find anything, but it gives you a full log of what it deleted. So you're never in the dark. It will show you what had a problem. So that's a good one to run. And after you run it, do a test render. If everything looks good, save your scene. So then the next part is just a quick overview of caching, and that can be a whole class on its own, so I'm not going to go into super detail about it. But the two main caching methods, I should say, that we use in Maya, it has a lot of them. Geometry cache is still useful. It's still used for XGen and things like that. Still good. Houdini uses it, right? But Alembic caches are the more popular, more sort of flexible one because they're platform independent. And then there's also the Arnold AS file, otherwise known as a stand-in, right? So the differences between these two are essentially they do the same thing, except Alembic caches work with pretty much all the software, including Nuke and Fusion, and I think After Effects is getting a few plugins that work with that, whereas Arnold only works with Arnold. So there's your choice. However, Alembics don't have surfacing information on them. They save the labels, right, where the materials are applied to, but doesn't actually save any information about those materials. Whereas Arnold is all there, which is why it's specific to Arnold. So it'll save all of your texture, all of your data, right? And to do an Alembic cache is, if you haven't done one, essentially you can select on what it is you want to cache, and you just do cache, Alembic cache. You do a export selection or export all if you like, right? And essentially, you know, there's time slider. This is all, you know, one-to-one, whatever your settings need to be, right? And then there's a whole bunch of settings down here. And when I tell people, they ask me, what do these do? I don't really know. But I know what a few of them do. I mean, they're self-explanatory. So UV right, you got to click that, because otherwise there's surfacing information. Whatever is left, like the labels, that goes away too. So you need that, at least that, right? The other ones like these guys here, those are also useful. The rest you can experiment with. Some people need creases in their objects. Some people need to strip their namespaces. Some people want to see no normals, right? So you kind of click that. But the one that you got to do is UV right, at the very least. The choice between the file format, Ogawa is newer, so use that, right? But HDF5 is also fine, right? This one is more compatible with other software. And what this does is it will, if I run this, if I export selection, it will ask me where to save it, right? I can name it T-Rex, right? And there you go. It went bloop, nothing really to animate, right? And you can see it saved it. And if I go in my file here, you'll notice, let's see if I have it. Where did it put it? There's my cache folder, Alembic, and there's T-Rex ABC. So what does this do? An Alembic file will save the vertex data of your shot. So essentially what it'll do is it'll just bake your animation down for any deformations you want. So I will cut this short. I'll also later on, I can go in another class about it. I have more notes. We'll go over all this eventually. But we have Josh.
Yay!
And you'll continue with that. All right. Come on in. How are you doing? Good. All right. So now we're just going over caching a little bit.
Oh boy, caching.
Yep.
So we already introduced you. We showed
Yes.
your website. We showed
And we'll
your
go over more of
Instagram,
this,
your
and if you
Twitter
want notes
picture.
on it or whatever, maybe next
So let me do that real
class.
quick. I'm just want to
check it
grab.
out,
I just want to grab that example file.
Sure. And
All right.
to keep mine in the bargain, I'm gonna go get a nice.
Oh, I was
All
joking, but if you want,
You're gonna get.
That's
you get a
awesome.
deal.
Nitro
That's-
coming up.
hell yeah.
All
Love
right.
it.
If you need it.
Okay. Thank you. All right.
All right. I just want to grab my example files. And this computer is huge.
It's massive.
I'm great. How you guys doing?
We're doing.
You doing? You guys ready to party? Yeah.
I gotta say, like, I think I told you, like, of all the talks, I think this is one of the ones that they're the most excited about.
Are they?
Oh yeah. We're
You guys
hyped.
excited?
We're hyped. Yeah.
Well, there we go. Yeah, let's grab that.
It's okay, it pierces all the eardrums.
How do you download? Hi. Download. There we go. Sack boys, yeah, woo! So if you showed you my Instant Poop already, you should know what the Sack boys look like.
Yep.
They're going to be my example files for today. We're going to talk about Redshift, a little bit of V-Ray, a little bit of Arnold, and maybe some strategies on how to split things up for your render. Yeah. All right. Is that everything? Cool. Does this thing have 2 hard drives?
Yep.
Cool. This thing is fancy.
Oh yeah.
It's like the size of my first car.
It's SD card readers.
Oh my god. It's got alien probes and
Oh yeah. It's got a jet exhaust on
I'm surprised you didn't make the nitro cold brew from this thing.
it.
Uh, God, it's so clicky.
Yep.
Okay.
One thing about the laptop is I have to say I'm slightly embarrassed. I mean, I'm getting old, I guess. It took me 10 minutes to figure out how to turn it on.
How do you turn?
Yeah, how do you turn it on?
You have to like put the crank wheel in and
Industry secret.
yeah, exactly. Or it's like Star Trek. It'd be like, "Hello, computer."
That's right. Talk to that white voice.
Yeah, exactly. Come on. For those of you who've taken class with me before, you know what I'm about to do.
Oh,
Here we go.
it's fine.
Oh, you two got low enough. It's thinking about it.
It's thinking about it. All right, I'll continue. It is lo-fi.
You got me addicted to Wednesday.
Good. Lo-fi is life.
It helps me focus, though, not gonna lie.
Exactly.
You study the
Exactly.
Oh, for some blanks. Just to triple thing. Oh, you're so gonna know what you we did all Yes!
There we go. All right. Woo! All right. Is this already? Oh, it's already recording. Great. Cool. Oh, dude.
Yeah.
Cool.
You'll notice the keyboard is reacting to the music.
Oh my god. The future is now.
I don't know.
All right. Hey, so we're gonna talk about Redshift, which is the future of rendering.
Yeah.
Or I guess it's already out, so it's not really the future anymore. So let's actually, before we go to the Sack Boys, let's start it nice and simple. with a sphere. And let's start out with a ground plane. Cool. So Redshift GPU renderer, one of the fastest renderers I've ever used. When you install it, you'll notice there is no shelf for it, but there is a menu for it. It has its own render buffer, and with no lights and only Lambert materials, it looks gross. So obviously that's to be expected, and obviously Redshift, just like every other PBR renderer, has their own lights. Now, if you've used Arnold, which I think everyone has, you should. A lot of these should be pretty recognizable. Your physical lights and your dome lights being your most used lights. I don't know how many of you use IES or portal lights. They're very specific for purposes, so we're going to stick to physical and dome light. So let's add a dome light. And I think I have an HDR. I do have an HDR. So we'll start with an HDR at first. So just like an Arnold, you load up a dome map, and let's hit play. Okay, so we're starting to get something now, and you can see how fast is that feedback. It is super fast. Now, obviously, this is only a sphere, so it's not the greatest example yet, but super fast feedback. Really, really cool. Alright, so first thing we want to do is add a new material, and just like in Arnold and V-Ray, Redshift has its own Uber shader known as the Redshift material. It's a very creative name, I know. And so, obviously, everyone's favorite thing about shaders are their presets. Yay, they're presets. So, real quick, we can get really cool looking results very, very fast. And unlike Arnold, you don't have to worry about checking on and off any opaque checkboxes. Things are opaque or transparent based on the shader, not based on the shape level. So if you're familiar, you should be familiar by now with the PBR workflow. So a lot of this stuff should be very familiar. If you're used to Arnold's way of a PBR workflow, you're probably used to a medalist workflow. Down in the Fresnel type, you have your medalists. If you're used to V-Ray, then you're probably used to the IOR workflow. And these other two are just variations and kind of mixed, like a blend between these. So usually when I want to switch to like a GGX PBR, and we have our subsurface scatter, but when it comes to Redshift, it has its own subsurface scatter material. It has two of them. It has subsurface scatter, and it has and Redshift skin. For those of you who wanted to texture your texturing characters or anything, Redshift skin is the more physically accurate material. It's a little bit of a pain to use, but if you're going for any kind of stylized character, or if you want to use subsurface surfaces like marble or wax or leaves on a tree, Redshift subsurface scatter is pretty awesome. And again, it has presets. Yay! So, what's that?
There was a potato.
Yeah, it's always a potato option. So, potato is a subsurface material. It's obviously not talking about potato skin, but that nice, soft, mushy insides. So, this doesn't look very subsurfacey, I know. When it comes to subsurface materials, you're not going to get a great result using a dome light alone. So let's go and check out the V-Ray physical lights. So by default, the physical light is just a normal area light. And now you're starting to see there's a little bit of subsurface going on. Let's switch this to, skin. And if I make this flat, we're going to start seeing the ability for the light to bleed through. And so subsurface scattering is one of the most render-heavy materials. And in Arnold and V-Ray, for those of you who played with those, if you want a production quality subsurface scatter render, you're talking at least half an hour, 45 minutes. But in Redshift, you don't really have to wait more than 2 minutes for a production quality render with subsurface scatter. So, for those of you, obviously your characters may not be this flat, unless they are, but if they are not, the one thing you really need to mess with is the scale right here. So, use up the scale, it'll allow the light to penetrate through much easier. So we go to our diffuse and scatter layers. We'll be plugging in your epidermal layer and on the subsurface color, and your scatter color, which is basically, you know, when you hold a flashlight to, I don't know, your ears or your hand to get that red, shows the blood, that's your scatter, so that's where you'll get this beautiful look here. So we make it like red, it's very bloody now. Actually, it's like, kind of like jello, I guess. And you can play with your scatter radius, which, as you can see, is just making it more and more translucent. Anyway, let's bring that back. Is that a question? So scale is calculating the subsurface and the scatter radius, which is basically how much it's bouncing around inside and how much it's penetrating through. Scatter radius alone is just how much it's bouncing around. So they give different effects. Really, the best thing I tell you to do is experiment with both to really kind of see what they both do. But I would say that I don't mess with scatter radius very often. I mess with scale the most because the scatter radius, I usually let one of the presets dictate that for me because it's pretty accurate. So you can skim it over. Yay. Alright, so I'm going to switch this back to a Redshift material, and let's go back to something like gold. That looks nice. Actually, let's do something a little bit more matte, like paper. Where's the paper? That's here, Jay. Shut up, Jay. So, alright. Let's start talking about 3-point lighting. Well, it's not going to be less than 3-point lighting. You guys have 3-point lighting right now, right? Better. Nah, you're screwed. Okay, so, I never know why by default you say you're screwed. 3-point lighting is very easy to learn, and it's the most essential lighting that you'll ever learn. It was developed, what, 300-400 years ago? No, more than that. Long time ago, by the great painters like, I don't know, all the ones named after Ninja Turtles. And, so, by default, visibility is turned on. I don't never know why, because these lights are ugly, so turn the visibility off. And let's see, you got your color, your temperature. I always like to play with temperature, but also remember when it comes to any kind of PBR system, only play with the exposure, do not play with the intensity. And I'm not even sure why they give you the intensity to play with, because as soon as you mess with intensity, you break physical accuracy. Which, yes, I know some of you, or a lot of people, want to play with like stylized renders, but when you break this intensity multiplier to a pretty high degree, you just get really weird artifacts that can't be removed. So try to stick to playing with your exposure. So you can change the shape of your light, and one of my favorite things right here is the spread. The spread is basically the degree at which it turns from a area light to a spotlight. So in other words, it's focusing its power. As you focus the power of this light to a smaller degree, it gets hotter or it gets more intense. So the less you make this spread, the less you need to break down the exposure so it's not blowing this thing out. So let me make this not so spread, something like that. And let's get a decent looking rim out of this, which I like to say is arguably the most important light. Whoop, burned out. Alright, something like that. And this will act as my key. Where's my fill light? The dome light's my fill. Yeah, laziness. You could also obviously put one more for your fill, but for the sake of time, this will look fine. Okay. So, you know what would look really good right now? Some environmental fog. Redshift is really easy to implement fog. We're going to go to our render settings. We're going to switch to Redshift. And let's just up this resolution a little. And we're going to go to output. We're going to play with a few things. So first of all, let's go down to environment. Click on the checker box next to environment, and we're going to add we're going to go to atmosphere. Sorry about that. And we're going to add a volume scattering. Look how beautiful that fog is. Okay, so we're not seeing any fog yet because you have to activate it on a per light basis. So if we go to the lights, you'll see right here, contribution scale, and as soon as I turn it up, fog. So, pretty awesome. And it works even better when you start bringing the spread down. Yeah, it's pretty awesome. I love playing with this stuff. Yes, you can do comp, or you can do like post fog, but it's never as sexy as 3D fog. That's the good stuff.
Okay.
Yeah, pretty awesome. So, be careful about your contribution scale. If you crank it up all the way, it can blow out your scene pretty easily, but obviously you can always compensate with your exposure settings. Okay, so we have our fog in here. What else makes a render sexy? You guessed it, depth of field. So, traditionally, depth of field is handled when it comes to V-Ray and Arnold. If you're not a big fancy studio like Pixar, you usually can't afford the really, really tough render times that depth of field gives you. But since Redshift is so fast, depth of field can be handled in camera, which is such a cool thing because in camera depth of field will always look better than post depth of field. So to add that, we're going to create a new camera, because we're not going to do it to our respective camera, right? We leave that guy alone? Probably. So let's add that, and I'm just going to call this my shot cam. Let's turn this down a little. Okay. So let's look through that shot cam. Oh, let's try that again. There we go. And just remember, because it took me a while to memorize this, I'm like, why isn't this working? It locks to the camera that you started with, so remember to switch it, because that's really annoying. I've literally restarted Maya 50 times before realizing what I had to do was switch this. So, my mistake will be your game. I don't know. Anyway, so to switch over to, or to add depth of field, we're going to click on the camera. We're going to go over to the camera shape, and we're going to scroll down to Redshift, and we're going to add a lens shader. So let's go down to Redshift, and the Redshift depth of field is called the Redshift bokeh. Do we know bokeh? Beautiful, isn't it? I love bokeh. Look at how awesome that is. Gorgeous. So, depth of field obviously needs a focal depth, or a focal distance. We're going to go to display, heads up display, poly count. And now when I click on something, I'll know how, not poly count, what the hell is wrong with it? Excuse me, object details, there we go, because, you know, distance from camera is what we're looking for. So we're at a 54 distance. I don't know why I didn't that's crazy. I'm going to turn off derive focal distance, and I'm going to type in 54, and we get depth of field, which would look better if I had some stuff in the foreground and the background. More balls. And let's just add a few more. Now we're getting depth of field. Exactly. So we're getting our depth of field, we're getting our fog, and this thing is still eating it for lunch. That's how awesome Redshift is. If you did try to do something like this in Arnold or V-Ray, especially on a laptop, it might die a very painful death. So it might be a little annoying to always, look for the distance to the camera and then like animate it in. So you can make it a very easy camera rig to make that automatic. And this will happen, you can do the same thing with Arnold and V-Ray as well if you want to just have like a tool to automatically focus in on whatever you want. And let's do that. So I'm going to turn this off for a second, and I'm going to go to perspective. This is our shot cam, sure is. So I'm going to go to my side view for now, and I'm going to go to create, distance tools, measurement tools, distance tool. And it doesn't really matter, I'm just going to click on 2 places just so I can get this thing created. Great. Okay, so this locator, I'm just going to get that point constrained to the camera. So let's point constrain, make sure the maintain offset is off so that it automatically snaps to the camera. And this locator here is going to be my target. So no matter where I'll just make that bigger. Okay, so wherever I put this target, I want the camera to be in focus. Well, how do we do that? Oh, look at that. We have a little distant dimension. Let's go plug that in. So let's go over to, not the perspective, our bokeh thingy. I'm going to copy this tab. And let's go to the distance dimension. I'm just going to grab my node editor, might make it a little bit easier. And distance dimension, let me add that to the mix. And I think it's that one. Does that have the distance dimension? Where's that one? Where are you? Distance, perfect. So with that selected, we can go back to bokeh. I love saying that word, so I'm saying it over and over again. And I'm just going to plug that. Oops. Plug that. That's now some little weird to distance. And so distance will plug into, where are you? Probably. Where do you see that? There it is. Hey! True detective. Want to switch places? Ah, I get it. I see what you did there. So now, wherever I move this guy, let's just get a good position. We have this great little tool that'll help us focus anywhere we want. So it's focused there, and then all of a sudden it's focused somewhere else over there. So very helpful for those of you who want to have a dynamic focal camera control. You can see it's very fast and very easy to set up. Okay, so what's next? What else is cool about Redshift besides everything? So there's a denoiser built in. Whoops. Denoiser right here. There are 2 engines when it comes to the denoising. There's optics, which is, comes free with Redshift. However, it's not quite prime time for production renders. It's really good to get quick, like test renders. However, it's a machine learning AI assisted denoiser, so it still needs time to learn. The estimation is still a couple months before it's production proven, but every update that Redshift comes out with, optics gets better and better and better, but it's still not ready for prime time. The Altus render, denoiser is production proven. Unfortunately, you need a license of it to actually use it. But this is the one that's also hooks up with Arnold. However, at the end of the day, denoising, whether you do it here or if you use something like Video or a Red Giant plugin, they're all basically doing the same thing. Again, this just kind of appeals to my laziness because it's right here. The other great thing about Redshift is you can do in-camera motion blur super fast and super easy. So let me just grab a sphere and let me animate it like a boss. So 1, 2, boom, look at that animation. Best animation ever, yes. Let's go to Redshift and let's turn it on. And if we go back to, not IPR, we go back to here and enable depth of our motion blur and turn on transformation and hit play, we get really sexy motion blur really quick. So this is it when it's off, and here it is when it's on. Motion blur always makes things look better. And again, in-camera motion blur always looks better than post, but you know, post is perfectly fine if you want to do it with Arnold. So next thing I want to talk about is AOVs. Actually, before that, I just want to talk about GI real quick. If you're dealing with Arnold, there is no option for GI because GI is just turned on automatically. But these primary and secondary engines are very reminiscent of the ones in V-Ray, so they basically have the same ones. If you want the most accurate GI, and it's the GI that's set by default in, or that's the only option in Arnold, brute force gives you the most physically accurate GI. It's also the heaviest one. When it comes to Redshift though, that doesn't really matter. But now all of a sudden, you're seeing that the ground is bouncing its light into the bottom of this sphere here. Let me just turn off motion blur. But you can see now without and with makes a hell of a difference. All that color, all that light bleed and all that fun stuff, you can only really get that with GI. Okay, so, and if you want something that's a little more affordable in terms of render time, especially for V-Ray, your Radiance Cache and Photon Map would be an excellent choice. It's not as physically accurate, but it is 1/10 the time it takes to calculate. In V-Ray, I believe let's just see real quick. Let's turn it off. In V-Ray, GI, turn it on. The Radiance Map and Light Cache is what you want to pick. This is like the safe kind of GI in V-Ray. Turn it off, go back to Redshift. Alright, so AOVs. Arbitrary output variables, or easy way to remember it's called render passes. You got a lot of render passes at your disposal, but I gotta say that unless you have a really specific reason to do so, I would suggest not really messing with the layers needed to recreate your beauty, unless you really think you need that much control, which a lot of the times you don't. That's a lot of extra stuff you'd have to do in post. My favorite thing to do is to render out every single light independently, and then that way you have control over the lights, and then render out a few matte passes, then you have control over your individual objects. Between those two, that's like 90% of what you need. So let's figure out how to set that up. In Redshift and in Arnold, this works the same way. If you go to every light, you'll notice that every light has something called a light group. So if you give the name, so my dome light, I'm going to call that fill. And I guess that was my key. And that third one we'll call rim. I'm sorry? I know, so picky. Alright, so we got all three. Let's go to our AOVs, and it's a little different from Redshift to Arnold, but I'll show you both. In Redshift, all you have to do is create a beauty pass, and inside your beauty pass, just hit all light groups, and then all of a sudden you'll see that when you render it out, that we have all of them right here. There they all are. So we have our rim, our key, and our fill. When you add them all together in post, you get your beauty, and then you have the added ability to key on and off different lights and different intensities. And that's the amount of control I like having on a beauty layer, that and the matte pads, or the mats. So mats are super easy. Let's create some mats. Who's laughing? There's no laughing in this class. So they immediately break the rules. All right. Is Jay causing trouble? Jay, get out of here. So in Redshift, it's called Puzzle Mat. This is our RGB mat passes. If you go and check out its options, basically you can assign to every material or every object what kind of mats you want. So let me just go to an object here, and let's go to its shape layer or shape node and turn on 1 for object ID. Let's do another one for this one. Never give anything an object ID of 0. A lot of the time it confuses the computer, because anything 0 is usually off. I've come across weird issues by giving an object ID of 0 to things. So we have 1, 2, and 3. When it comes to puzzle mats, you can only do 3 objects at a time. That's why sometimes if they're sharing the same material, you might just want to do it to the material level. If you want to do it to the material level, go into the hypershade, go to the shader group of the hypershade, Redshift, there's your material ID. Okay, so now that I have my puzzle mat set up, oh wait, the other thing is you gotta make sure you set up 1, 2, and 3. I also like that you can actually reflect and refract IDs. So if you have something glassy in your scene, it might be cool to turn that on. Also, let's switch this to object ID. Let's take a look. So let's go to puzzle mat, and I have the ability now to control these 3 things in post. I got a whole bunch of objects here, so I'm not going to sit here and create 1,000 puzzle mats. That'll be your job. But obviously, like I just said before, if you have a whole bunch and they're sharing the same material, just do it to the material. So I don't know how many of you are planning on doing. So if you have like environments in your animation, let's say like trees or flowers or grass, and they're all being controlled through a scatter system. In the example I'm about to say, MASH. Those of you taking my classes before, you know I have a fetish for MASH. Let me turn that off, and let me just create a quick MASH network. Whoops. All right. So let's make that a little bit bigger, and let's turn on. Let's go to MASH editor and go to MASH. I'm good. Mouse is a little strange, but I'm dealing with it. Let's just do something like 100. Okay. So, for those of you who are doing scatter systems, again, like for trees or rocks or anything like that, you'd want to distribute them with MASH. The reason why I'm bringing this up is because if you distribute something that's 1,000 instances of the same thing, you might see that it's a repeated object. That's very obvious. So it's really easy to get variation in your objects by using like the color node, and then you can add something like let's do a bunch of variations. And so let's say that you have something. Let me just add a Redshift material, and on the Redshift material, this was where you would plug in. Let's say if you were doing this to leaves, you would plug in your leaf texture. But in my case, I'm just going to plug in a noise. Okay, so let's say that we have our leaf texture, But we want to add that variation of color in there. And you can do the same thing in Arnold and V-Ray very easily. Each one has their own version of this node I'm about to show you. So let's grab this and expand it. So this would be your leaf texture. So to get that color variation that we already added back in Mesh, this color node right here is distributing color through color vertex attributes. So Redshift has something called the Redshift vertex color. V-Ray has something. If you just type in vertex color for V-Ray, it'll pop in. But for Arnold, it's called the user color. So Arnold user color is how you're going to get to this same attribute. Right here where it says color set, if you notice going to the color right here, this is the name right there, color set. So we're just going to plug that right in. Right here. And so at this point, we just need to mix these two together. I'm going to do that with a multiply divide node. Plug that in. And let's go back to Redshift. And we're getting our color variation. And as we screw with all these different attributes, it'll update in real time. So it's a great way to get color variation over thousands of objects very, very fast. Okay, so I guess the next thing we wanted to talk about was that more render passes and render layers and how to organize them. Okay. So we created a beauty pass, and from this beauty pass we've also created light passes. I got my puzzle mat. Let me just give this a puzzle mat. Let's just do two more things here. Actually, this will be a great time to go to play with the sack boards. You have to find plugins to do it. Natively, no. Mesh is like the best way to do it. There's also, alright, so that's with Redshift. There is the AI color jitter node you can play with. That one takes a little bit of setup though, so I'm not going to show it now, but if you want a great resource on how to use the AI jitter node, color jitter node, check out Arvid Schneider's YouTube page. He has like an hour-long thing about it, so he'll explain all that. Yep. So let's see what we got going on for Redshift. That looks cool. Let's see what is going on here.
Women are all liars. You should know that.
See how fast it is? So fast. There we go. So I'm doing that color jitter thing on this as well. And right now I only have a dome light in here. So let's just get a little fancy and add a same thing as before. Let's add a physical light. And let's get even fancier and add a little bit of yes. This is the greatest thing ever. Yes, it is. Alright, let's go to atmosphere. And let's make sure that the actual contribution is up.
When I do, will you come with me?
It's oh my god. They are dying painful deaths, but it's for a worthy cause. So So let me, wow, this computer's really kind of starting to choke now. This might be a little too much. I'm going to turn off a few things, like mainly the denoiser. We don't need that right now. That should be enough to, let's just bring the contribution down a little bit so they're not getting nuked.
They're running for their lives.
Oh, they are. They can go all they want, though. They can't hide. I know. Don't worry, no sack boys were killed in making or actually pot more. They're dead. It's kind of.
That one on the side.
There we go. Alright, so that's fun. Okay, so for my AOVs, come on. Let's turn it off. I want beauty. They are a boy band. Oh, you know, can't be perfect. That's. So just take a quick look at the puzzle mat. Worst puzzle mat ever. That's the thing that'll allow us to create a mask per object. And I'm about to show you why that's such a neat thing. If it lets me. Maybe not. Oh, I get it because it's red. I'll say yes. It definitely wasn't a happy coincidence. It was completely intentional. So we have our beauty. Oh, right. So one thing I forgot to do is let's take this light, let's add a name. We'll call this Fogger. And we'll call this one Domer. And so Fogger and Domer. And we have our object ID set up. Sorry, what? Object ID, cool. This should be everything. You're seeing right here this translating seed data. What it's basically doing is it's sending it off to the graphics card. And kind of. Totally seems like it. Why is my puzzle mat not working? God damn it. I did it, yeah. See? I got object IDs on. I'm not completely stupid. Just partially. I know, I'm so self-deprecating. 1, 2. Alright. So, we at least got these guys. Let's also turn on, let's see, I'm going to turn on volume lighting. That one looks good. And why aren't you working? Yeah, they all need to point to an object ID. In this case, it's working like a charm. The beauty of Maya, right? So I'm just going to delete this puzzle mat, and I'm going to add one back in. Could have also had a crypto mat. You guys know about crypto mats? Do we have a crypto mat installed on the new? Okay, so we'll just try that real quick. And we'll do a puzzle mat. Fuzz mats. you. Damn it. Getting some really weird glitches though. I like the fogger here with this thing. Let's just go to a simple scene so I can quickly get this going. We're gonna go back to the good old 3-sphere process here. This is white. Add one on one side and one on the other. Crypto mat, puzzle mat, and what was the other one I was doing? Volume lighting, thank you. One more. Oh, the beauty. We'll call this A, we'll call this B. Well, this is recorded, so you can always look at it later too. If you can't read the words now, then read them later. That's it. Me 3. Alright. Let's make sure this is working now. It's blowing out, but I just want to make sure it's working. Oh, I forgot to set up my puzzle mat, so make sure it's object ID. 1, 2, 3. 1, 2, 3. There they are. Hey, puzzle mats. It's like a traffic light, except, well, no, it's not at all. Wow. Blah, blah, blah. I don't want to hear it. I didn't say I had common sense. Alright. You're blue. Alright, okay, so we got our layers. We got our lights, I think. We have our beauty. And we just need to go to the AOB, beauty, all light groups. That should be it. There they are. Beautiful. Okay. So, we'll do one final render for this very ugly render here, but it's just to prove a point. And we have everything. Yeah, crypto mats are awesome. I'm about to show you what that is. So I'm going to save this as EXR. We'll just call this balls. And so, how many of you know how to use Nuke? And how many of you know how to use After Effects? Okay, there's more After Effects than Nuke, but so we'll do them both. So raise your hand, both. Alright, so CryptoMat is the first one I'll show real quick. This is a plugin. CryptoMat is a plugin that Psyop created that allows us to basically have infinite mats. And so if you take a look at CryptoMat, you go to, let's see, go to Add Picker, and you basically pick one of these. It allows me to see it. You can go up here to CryptoMat, so I'll pick like that one, and you'll notice right away I have no health. Nice, that's awesome. Let's go back to RGBA. Ah. Well, normally you would get an alpha at that point. That would be your mask. Anyway, we'll move on. I'm going to create a shuffle node. And let's shuffle out a puzzle mat. And so, this is kind of the beauty now of having these mats. I can mask in to a gray node. Let's say I want to just change the color of just this one sphere over here. I can mask by red, and then I can, let's say, multiply it by orange, and I can make that one orange. So you have absolute control in post over the color of individual things. So if I want to do it to another one, I can add another grade node, plug it in, and now do green. And this guy now, if I multiply it by green, it's green. And you can do the same thing with a color correction node. If you want to like play with the gamma of something, you would, instead of the mask over here, you gotta go to ranges, and what's this one, blue? I'm gonna go to my RGB blue. And so now I can have absolute control over the contrast of something. There we go. Let's play with the game a little bit, so I can not have it so blown out. What other passes did I just do? The beauty reconstruction. So, in my view, that beauty reconstruction consists of just combining your lights. So let's do shuffle. I'm gonna grab a beauty, and I'm gonna grab postage stamp, and then I'm just gonna copy, paste, into beauty B. Beauty C. So we have A, B, C. And so now that we have these three, we can merge them all back together. Setting M to merge. And we want to switch our operation to add, or plus in this case. So it looks just like beauty, but now we can go to each one of these different lights here, basically. Maybe we'll organize this so it doesn't look like a complete disaster. Just plug that in. There we go, something like that. Alright. So now I can go to grade, and let's say, you know, it's burned out on this side. I can just grade it down a little and have control of my lights in post. And to me, that is the most powerful thing you can do for your animations, have controls over your lights. And even better, you can actually add a little bit of temperature. So I put a little bit of blue on this one, and a little bit of, or let's see, a little bit of red. So to me, I think this is much more important than being able to recreate your beauty with having control of your. Yes, it's nice to have control of your specularity and all that kind of stuff, but you kind of want to get that right in camera for the most part anyway. So if you want to do that in Arnold, which I think is probably what most of you are going to want to do, how much time we have? Okay, a little bit of time. So let's switch gears to Arnold. So Arnold is just a little bit different in terms of how you set up your light groups. You go over your, so let's create some Arnold lights. So we'll do a sky dome light, and we'll do an area light. We'll do the exact same thing we just did with the Redshift setup. This hour really went fast. It's crazy. So, same thing like before, when it comes to creating light groups in Arnold, you have your light group on an every light basis. So we can call this one right, we can call this one left, and we can grab the dome and call it domer. So it's a little bit weirder in Arnold. You gotta go to your AOVs and you gotta create a custom AOV. And so now you gotta type in the prefix RGBA underscore and then the name of the light group. So I'll say donor. And that would give you just the RGB of donor. But if you wanted maybe, let's say, just the reflection or just the specular of that given light, you go to add custom and you can type in specular underscore donor. And you can do the same thing to the other lights, RGBA underscore left, and finally RGBA right. Just to let you know, because I'm sure many of you are going to want to render out a depth pass in Arnold, the Z one that's done by default is kind of funky. There's something really weird about it, in which if you render out a Z pass that has an alpha, anywhere that's alpha is infinity. And you'll get this really weird problem in Nuke where it says NaN, which is like this error message for anywhere that's infinity. And so when you go to actually use your Z defocus in Nuke, you'll get really weird halos and artifacts around every area. So the workaround that I know of is creating a, let's see, where is that guy? Actually, I think it's just creating another custom RGBA underscore beauty. And so I created this custom shader, RGBA beauty, and I'm just going to go to the node editor, and I'm going to create a sampler info node. And where you see it says point camera, let's go back to, there's our, where it says shader, we're just going to plug, obviously need a shader to plug into, so I'm just going to do a surface shader. And so I'm going to do point camera to out color, which is going to give us this little weird green. That doesn't matter. And let me go back to RGBA beauty. Instead of beauty, maybe I should call it something more, make more sense, like depth. And plug the shader into shader. And what we get is RGB depth. Let me just go to my pixel information. You plug it in to out color. Yeah, so let's take a look at, and trying to show basically, well, there's not a lot of depth in this scene, but basically what you're looking at is right here. If you look at this RG and B, okay, it's all zeroed off, so that's working out great. If it's a very depth, there's a lot of depth to the scene. What you'll end up seeing is a value here, and so you basically would use this exactly as you see a depth pass in Nuke using the Z focus node, and you would get the same exact result without that weird NaN problem. The other fix you can do is that just remember to put a gigantic plane in the background of your scenes, turn off its visibility. Just the problem with that is you'll have to create some sort of custom masking, because obviously you're going to want want to have that mask to put in your own backgrounds. That's why I like this method better, because you're just getting a depth pass without the error, without the infinity. Anyway, if we look at the other shapes or the other passes real quick, you'll notice that they don't work at all. Beautiful. Well, not sure why it's not working. I apologize for that, but I guess we're gonna have to end it on that awesome note. But anyway, what's that? Really? Just gotta take my word for it? I could be completely full of shit. But good, I'm glad you take my word for it. Thank you.